Bush are 18 now. You're 19.
Wait, what?
Here we go. We're going to pick up where we left off. Kids, for a lot of you, it's going to be brand new stuff. We really got to stay focused. Mrs. Ford has 8 jumpers and 10 shirts. How many different outfits are possible? Anybody want to take a stab at that? Okay, well, stop and think about it. This shirt can be paired with 8 different jumpers. So with this shirt alone, I have 8 different outfits.
So do 8, 7, 6, 5, 4, 3.
Nope. So what about my blue shirt? I have 8 outfits for it too. So every shirt has 8 outfits because you can put it with 8 jumpers. So since there are 10 shirts, there would be, how many outfits? 80. Exactly. The fundamental counting principle says if you can do one thing n ways and you can do another thing m ways, you can do them together n m ways. So think about it like this. I go to my closet. I have to pick a shirt. How many shirts do I have to pick from? 10. So I have 10 choices. And in mathematics, and means to multiply. I have 10 choices of shirt, and I have 8 choices of jumper, so I have 80 possible choices. Mr. Ford has 5 sport coats, 12 shirts, and 10 pair of pants. How many outfits does he have? 5 times 12 times 10. Yep, so what is that, 600?
Yes.
And I only have 80, he's got 600. How many ways can the home row of the keyboard be arranged? So how many letters are there? 9.
9 to the
9 factorial, exactly. Because basically what I'm asking you is, how many ways can we arrange those 9 things in a line? Doesn't matter if they're letters, doesn't matter if they're people, doesn't matter if they're books, whatever they are. How many ways can I arrange 9 things in a line? 9 factorial. And you need to, when you do this, you need to actually write down the number. So remember how we do that? We go to our we go to math, probability, and then choose the exclamation point. So 362,880. Remember, 9 things in a row, no matter what they are, 9 things in a row is 9 factorial. How many ways can you answer 10 true-false questions? Well, that's a good guess.
No. You have 10.
Okay, because you have what? Go ahead.
You have 10 questions.
Okay, so let me look at that. There's 10 questions.
And then there's 2 options per question.
Exactly. So there's 2 here, and 2 here,
okay,
and 2 here.
So 2 to the power of 10?
So 2 to the power of 10, multiply 2 times itself. This is exactly like the jumper shirt problem. How many choices do I have for each thing? Well, I have 2 choices for question 1, and 2 choices, and.
So then why would you just multiply 10 times 8 and not do the power in for the numbers and do powers for this one?
Well, these aren't the same number.
Okay.
If I had 10 of this and 10 of this, I could say 10 squared.
Okay, yeah.
That's basically what's happening here. How many ways can 4 different prizes be given out if there are 10 people in the contest? All right, so be careful. You have 4 prizes to give away. Okay? So somebody's getting a marker, a pencil, an eraser, and a piece of chalk.
Would it be 10 times 9 times 8 times 7?
It would. 10 times 9 times 8 times 7. That's exactly right. Think about it for a second. I'm going to give away this marker. There's 10 of you here. I'm going to give away this marker. How many choices do I have to give this marker to?
10.
10. Okay, so I've given it to Julianne. All right, now I'm going to give away my pink eraser. How many people do I have left to give the pink eraser to? 9. And then the next thing is 8, and the next thing is 7, and we're done. Okay, so we can type in 10 times 9 times 8 times 7. We can type that in. We can also, I can't remember if we talked about this the other day, we can also type this in on our calculator. Sometimes this is written like this, but normally it's written like this because that's how it looks on our calculator. Now, what that P stands for, did I talk about this the other day?
No.
What that P stands for is Perm Mutations. And what we mean is there are 10 people to choose from. I'm going to choose 4 of them to get the prizes. And the order I choose them matters because the prizes are different. Think about it. If I'm giving away a calculator and a marker, and the first person I pick gets the calculator and the second person gets the marker, don't you want to be the first person I pick? So you get the better prize? Order matters if the prizes are different. Now, if everybody I picked was getting a marker, then you wouldn't care if you got picked first or second, you just want to get picked, right? When order matters, permutations. Order always matters if you're giving out things that are different, or if you're assigning different responsibilities. Just remember, if they're different, if we're picking for different reasons, then we're going to use permutations. To type this in on your calculator, press 10. Then go to math, over to probability, and you see an option called NPR. Press it, hit 4, and you get 5,040, which should have been what you got when you times all this together. This will work. There's nothing wrong with this. You are welcome to do this. It gets a little inconvenient, if there's a lot of numbers, but this means the same thing. So again, this means there are 10 people. I am choosing 4, and the order I choose them matters, because in this case, I'm giving away different prizes.
So could you have done this one with the first, second, third place race contestant thingy?
Yep, absolutely. It's the same thing.
Go ahead.
So what he's talking about is back up at number 3. When we did this in class, we probably wrote out 10 times 9 times 8, which is fine, always work, 100% perfect. But you could also say 10P3, because there are 10 kids in the race, and you're choosing 3 of them, and the prizes they're getting are different. Somebody's first, second, and third. Order matters. So 10P3 will give you the same answer. All right, number 9. How many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits? All right, so what's my license plate look like? It has 2 letters followed by 3 non-zero digits. Digits are numbers, but can't be 0. All right, so it's like going to the closet, picking a shirt and a jumper. I got to pick a letter. How many letters are there to pick from?
26.
26. And
26.
I have to pick another letter.
26.
Well, time out. In a license plate,
You can have 26.
can you have the same letter twice?
Yes.
Yes, you can. Go look at the parking lot. Now, sometimes you will be told, don't repeat. Then it would be 26, 25. But if you're not told that, you got to think about common sense. Can I have a license plate with the same letter in it? And you can. There's nothing wrong with it. All right, now I need a non-zero digit.
Times 9 times 9.
999. And multiplied, guys, because you're picking a letter and a letter and a number and a number and a number to make this license plate. So we just type 26 times 26 times 999. Now, number 10, and I know you can type that in. On a test or quiz, you will. You don't necessarily have to do it right now unless you just want to. How many plates, so we're repeating the problem. How many plates are possible if nothing can repeat? So I want the same style of license plate, but nothing can repeat. So what's going to be different about this setup? Donovan?
It's gonna be 26, 25, 9, 8, 7.
It is all multiplied together. You multiply all your choices together. So does everybody see the difference in the way the problem is worded? If you are told that you can't repeat, then you can't repeat. All right. You guys probably watch TV or listen to the radio. I'm a big Chuck Lofton fan, so I watch Channel 13, which is called WTHR. That's called a call, that's the call sign, WTHR. So that's what we mean in this problem. How many call signs are possible? 1, 2, 3, 4. If everything goes, you can have anything, no rules, anything goes. How many would be possible? Gabby? 35?
Yeah.
How'd you get that?
There's 26 letters and 9 numbers.
No, a call sign, they're 4-letter call signs like WTHR, 4 letters. So it would be 26, 26, 26, 26, wouldn't it? 4 letters. Now, I don't think in real life that's allowed, but it says here every letter is allowed. Now, what if you cannot repeat? What would it look like if you can't repeat them? You can't use a letter twice. Tell me.
26, 25, 24, 25.
Yep, that's if you can't repeat. So this would be the answer to number 11, and this is the answer to number 12. Now 13 says, same thing, we're building a 4-letter call sign, but we can't use vowels.
Are you counting Y as a vowel?
No.
So 21,
21, 21, 21, 21, all multiplied together because there are 5 letters traditionally considered vowels. Pull those out, you have 21 left. How many are possible if no vowels and no repetition? 21, 20, 19, and 18. A baseball team has 9 starters. How many different batting orders are possible?
Wouldn't that be 9 factorial?
9 factorial. Pivot. I'm the coach. I'm getting my batting order arranged. You're gonna just line up my players in a row, say you're first, second, third, fourth, fifth. How many ways can I arrange 9 things in a row? 9 factorial. Well, what happens if my pitcher has to bat last?
Would it be 8 times 8 times 8, and then the last one would be 1?
No, but the last one would be 1. That part's right. And the first one would be 8, because here are 1, 2, 3, 4, 5, 6, 7, 8. Here are my 9 players right here. I have one choice for that spot because he's the pitcher and he has to go last. So how many picks do I have to arrange? 8.
So 8 factorial?
8, yeah, this is just gonna be 8 factorial. 8 factorial, because Julianne, you're a softball player. If you bat first, can you then bat second? You're out of the mix. So whoever's here, no more. So now you have 7, 6, 5, 4, right? What happens if the pitcher bats last and the best hitter bats third? So
Okay,
there's
that's up to
one
7.
choice there and one choice here.
7 factorial.
7 factorial. Because think about it, guys. If you have pulled those 2 players out, how many do you have left to arrange?
7.
7 factorial, or 7, which would be 7 factorial. If you filled in the blanks, you'll see it. 7, 6, 5, 4, 3, 2, 1. There it is. 7 factorial. How many 1, 2, or 3-digit numbers can be formed from these numbers, sir?
Would you have, well, there's 999 well, like for 1, 2, and 3 digit number, that's 999.
Okay, now we need to back up a little bit because we're only allowed to use these digits.
Oh,
So, like, you could build a number 654,
okay.
but you can't build the number 891
Okay.
because we're only using those digits. Okay? What makes this problem a little bit different than the others that we've done is there's actually multiple scenarios. You are building 1-digit numbers or 2-digit numbers or 3-digit numbers, okay? So and you're only using these numbers. These are the only numbers you're allowed to use. Okay, so how many 1-digit numbers could you build from this pool? 6. Not 6 factorial. Stop, stop, stop. I have little pieces of paper with the numbers 1, 2, 3, 4, 5, 6 on them, right? I need a 1-digit number, just 1 digit. Couldn't it either be a 1, a 2, a 3, a 4, a 5, or a 6? Don't do factorial unless you're arranging things. I'm not arranging these. I'm saying how many 1-digit numbers can I make? All right, I can make 6. Now what about 2-digit numbers? Think about this for a second. There are the 2-digit numbers. How many choices do you have for this first blank?
66. Oh.
You have 6, right? How many choices do you have for that blank? 6. Think about 2-digit numbers. You could have 45. You could have 63. You could have 22, right? Using these digits only. So that's 36 of those. There's 36 2-digit numbers. Using only those numbers. All right, what about 3-digit numbers?
6 times 6 is 6.
Yeah, 6 times 6 times 6, so 216. So if the question said how many 1-digit numbers, 6. How many 2-digit numbers, 36. How many 3-digit numbers, 216. But it doesn't say that. It says how many 1-digit or 2-digit or 3-digit. What am I supposed to do with these numbers? Add them up. Add them up. This word tells you you're adding. Remember earlier I said if it's this and this, you multiply? Well, if it's this or this, you add. I hate memorizing junk like that, but it makes a huge difference. If you're doing X and Y, multiply. If you're doing X or Y, add. So I figure out the 1 digits, the 2 digits, the 3 digits, and I add them all up. So the answer would be whatever that is. 258. 258 numbers that you have. All right. How many ways can you arrange these letters? That's what this question's asking. How many ways can you arrange these letters? 5 factorial. You better never miss that question. 5 things in a row, 5 factorial. How about the word precal? 6 factorial. I'm going to skip a couple now and go down to 23 because it's the same idea. How about precalculus? I heard somebody say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factorial. But there's something a little bit different about this word
Those repeating
that
letters.
didn't happen with our other examples.
Those
Did you
repeating
hear what
letters.
Alexis said? We got repeats, don't we? We have repetition. Repetition has to be accounted for, so we're gonna deal with it. But, I wanna say, if the word has 11 letters, I don't care what the 11 letters are, you start with 11 factorial. Okay, that's the beginning. Even when they repeat, I don't care, you start with 11 factorial. To handle the repetition, we divide out those options. So since there are 2 U's, I divide by 2 factorial. That takes care of the U's. There are 2 C's, I divide by another factorial. Of each letter, factorial, individually. There are 2 L's, so I'll divide by another 2 factorial. If there were 3 of something, did I get it all?
Yeah.
If there are 3 of something, I divide by 3 factorial. If there's 4, I divide by 4 factorial. But however many repeats you have of each individual item, you divide by that factorial. Now, I do want everybody to type this one in, because remember, when you have more than one thing in the denominator, it has to be in parentheses. Okay? Izzy?
Did you not do 6 factorials?
No,
Okay.
no. Now, in this case, it would, you could simplify it, it's not 6. But if you wrote out 2 factorial times 2 factorial times 2 factorial, that isn't 6 factorial by any means, it's 8. So that denominator is 8. You cannot ever combine factorials. It just doesn't work.
You could do 2 factorial cubed.
Yes, you could, yep. Actually, I've never typed in a factorial cube. I wonder, you might have to put the 2 factorial in parentheses and then cube it.
Oh, I like just put 2 factorial cubed and put all of that in parentheses.
It didn't work?
It didn't give me an error, so.
Okay, yeah, I'm sure it's right. So, let me see what the answer's supposed to be here, so we can all compare. Did you get, 4,989,600? Yeah, then you got it right. So, I don't wanna make a big deal about it, I just wanna make sure you can type in this stuff. All right, let's do 24, Mississippi. All right, so now we're gonna do the same thing with Mississippi. So what's that setup gonna look like? MISS, ISS.
11 factorial divided by 4 factorial divided by 4 factorial divided by 2 factorial.
So there's 11 letters again, if I spelled it right. But this time we have
11.
4 S's,
4 I's.
4
And
I's,
then 2 P's.
and 2 P's. That denominator doesn't combine, so please don't try to do any shortcuts with it. We're just gonna type it in. And before you complain, I'll tell you what I tell you over and over again. Remember, I had to do this without a calculator. What'd you come up with? Kelsey, look up and smell the coffee here, honey.
138,600.
Ooh, that's not what I got.
I got 2,887.
I didn't either. Okay, so I must.
I got 34,000.
That's what I got. 34,650.
Yeah.
All right, if you didn't get that, try again. Make sure those are in parentheses. 34,650. All right, so we're all typing that in, making sure we know how, so we don't miss every question on the quiz. All right, so let's back up now. So we just did 4 letter problems. Like, here's a word, rearrange the letters. We understand what to do now, right, with that? a pretty common problem. Okay, now, number 21. How many social security numbers are possible if all arrangements are possible? Okay, I don't expect you to be a social security expert. I'm not, and I probably should be. But I'm not. But I do know what my social security number looks like, right? It's 3 digits,
2 digits.
and then it's 2 digits,
This is 4 digits.
and then it's 4 digits. So yeah, that's kind of common knowledge, you should know. I don't know how they make them up. Like when I had my kids and you apply for a social security number and they send, I don't know how they come up with those numbers. But in this problem, it says, how many are possible if anything goes? Anything goes. So if anything goes, tell me what this is gonna look like.
10, 10,
10, 10, 10, 10, 10, 10, 10, 10, 10. All times together, right? So what is that? How many of those are there? So that's 10 to the 9?
Why would it be 10?
What would you think it would be? 9? Is 0 a digit? And they're saying everything goes. So they're saying you can have all zeros as your number. I have a 0 in my number, actually, now that I think about it. Okay, number 22. How many telephone numbers are possible in the 317 area code? How many telephone numbers are possible in the 317 area code? So think about it now. You got 317, and then doesn't your phone number look like something, 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 something?
7 digits, so wouldn't it just
10 to
be
the 7.
arranging 10
And
numbers?
If anything goes, they
10 to the
haven't
7.
said anything,
10 numbers?
wouldn't it be 10 to the 7?
But are you arranging 10 numbers?
Anything's possible.
I'm building a phone number.
Okay, so it's not,
So I
okay.
have 10 choices for each blank. I am not taking my phone number and rearranging the
Okay,
digits.
I understand. Okay.
I have a hard enough time remembering as it is. I'm not doing any rearranging with my phone number. The kids in another class told me when we did a problem like this, that if you go to get a new phone number now, that it's not 317 anymore.
Yeah.
Yeah, it changed.
Now, why would that be? Can you think about why that would be?
They
They ran out. And why did they run out, Ollie? Because if we allow every possibility, there's only 10 to the 7th, which is 10 million. Now, back in the old days when I was growing up, that wouldn't have been a problem at all. Because every household, including mine, I'm one of 6 children, 8 people lived in my house, we had one phone. So 8 people had one phone number. Well, now think about your family. How many phone numbers are in your family? Everybody's got them. So it's obvious we ran out because everybody has multiple phones now. Throw in home phones, throw in business phones, throw in car phones, throw in all the other kinds of phones. They ran out. So what did they do? They created a new area code, and then that opened up 10 million more numbers. The new area code, I can't remember. They told me. Anybody know what it is?
540.
What?
Isn't it like 540?
I don't know. It's some kids told me. I have no idea.
That is weird.
Isn't that weird?
Yeah.
Okay. Number 25. Explain why at least 2 students at Cathedral must have the same first and last initial. Okay? Now, make sure you read that problem correctly. It doesn't say that we can guarantee there's another RS out there, although there probably is. We can't guarantee it. We can't guarantee that there's another JH out there. But we can guarantee that somewhere in this school population, 2 kids have the same first and last initial. How can you absolutely guarantee that? How many first initials are
26.
possible? How many
46.
second initials?
26.
So altogether, there are how many first and last initial combinations?
676.
676. How many kids are feeble?
1,000.
Okay. So if there's 11,000, 1,100, I don't know how many kids are at cathedral, but however many there are, it's more than this.
Mm-hmm.
And if this is all you've got, then there are repeats out there someplace. I know I used to be so excited when I met someone, when I was younger, when I met someone who had my birthday. I just thought that was the coolest thing in the world. Somebody else was born the same day as I was. Well, in my little world, I guess I only thought there were 365 people. I mean, obviously, people are going to share birthdays, right? Because there's only 365 or 366 options. All right. I love talking about this stuff. All right. All right, now I want you all to read question 26A and 26B. Semantics is everything. I want you to tell me, I want you to read these problems carefully, 26A and B, they both involved having 20 kids and choosing 2. Are they exactly the same problem, just worded differently, which is possible? Or are they actually 2 different problems? Read them carefully. And if you tell me they're the same, I'm going to ask you why you say that. If you tell me they're different, I'm going to ask you why you say that. So, Sue thinks they're the same. Sophia thinks they're different. Sophia, tell me why they're different.
Because when you're choosing a president and vice president out of the 20 members, then you have to take off like the 2 people that are going to be chosen out of the 20, and then it says how many ways to choose a 2-person governing council, and that's like all 20 people.
I actually think she knows what she's talking about, but she's not saying it exactly right. But I think she knows what she's talking about. Do you want to add to that, Abby?
Yeah, so for 20, the A, I would think it'd be 20 times 19 because you'd have to get rid of the 1 person that's the president. And then for B, I think it's 2 to the power of 20.
Okay.
20 to the power of 20.
So I'm going to buy half of what you said, okay? I'm going to take one more comment and then we're going to go on. Ollie, birthday boy, dying to answer. What are you going to say?
So I think the reason why this is different is because with the 20 people that you have, you need someone to take a president position, a vice president position. With that in mind, you would have to reduce that number down to 18, so there will be a 1, 2, 1 somewhere, and then these kind of separate. You would have to take out the 18, so that'll reduce it down to 16 because you need to find like 2 different people for a governing council.
Okay, you guys are all over this. We're all over the board, but I think we're pointing in the right direction. Colin, go ahead, because you had your hand up too.
Is it the A, the order matters?
Exactly. Think about it for a second. Okay, I always pick on them here. Okay, so there's 20 people here, and I need to pick a president and a vice president. Okay? If I pick him as president and him as vice president, isn't that different than if I pick him as president and him as vice president?
Yes.
But if I come in here and say, okay, you 2 are my leadership council, does it matter which one I pick first? No. So I want to go back to what I said earlier. If you are choosing for a specific prize, for a specific job description, order matters. So the answer to 26A would be 20P2. Now, that is exactly what several of you said. When you type that in on your calculator, you're going to get 20 times 19. P's can always be done that way. This is if order matters, okay? So order matters here, that's a P. And order matters when you're picking a specific job a specific prize, a specific anything. Order matters. If order doesn't matter, a leadership committee, doesn't matter. Prom court, doesn't matter, just want to be on the court. Order doesn't matter. Then it's what we call a combination problem. And that would be 20C2. C for combination. Now, once you type both those in, well, that one's 380.
So the second one, 190.
190.
Why are we typing in like for P and C?
We talked about this already. Go to where your factorial is and you will see those two buttons. You'll see them. But you gotta type the number first, and go to where your factorial is, press NCR, and then 2. Okay? Now, do the same thing with number 27. Read these two questions. Tell me if they're the same or different. And tell me how you'd set them up. Number 27. Abby.
27 be 13C4, 27 be 13C4.
13P4, yep, she's exactly right. What is the difference there? Same thing it was a minute ago. If you're picking jobs, president, vice president, etc., it's gotta be a P. It's gotta be a P. If you're picking just people to be in the group, then it's a C. All right, go ahead and type those in so we get practice. 13C4 and 13P4.
13C4 is 715.
715.
13P4 is 17,160.
160.
That's what I said.
When I was digging up some problems to put on this for a different class, listen to this, tell me if it's a P or a C. I've got 15 potential actors and actresses in my room, 15 of them. I need to pick 4 of them to play the Beatles. John, George, Ringo, and Paul.
It's gonna be P.
That's gonna be a P, because you're gonna be Ringo,
Yeah.
you're gonna be George, or you're gonna be George and he's gonna be Ringo,
Because it's
right?
like
Order
leading
matters.
versus
Okay,
supporting.
same 15 actresses. I'm gonna pick 4 to play the bushes in the scenery.
Ensemble, C.
That's a C. Right, they're all doing the same thing. They're all doing exactly the same thing.
So, question, what does, so P looks like when you like stop like the factorial
Yep.
thingy, what does C look
It
like?
doesn't.
It's
Can't
its own,
do it.
okay,
Because, sir, as soon as you put blanks up here,
yeah,
you've got to order first, second.
okay,
There's no order in combination, so you can't do that.
got it,
The only way to do a combination is to type in a combination.
got it.
All right, 28, what's different about 28? Tell me.
It's a circle.
Yep, we're not seating in a line. If these were 8 people on a log, it would be 8 factorial.
This is 7 factorial.
This is 7 factorial. When you arrange people in a circle, it's 1 less factorial. We talked about that the other day?
Yes.
Because there's no beginning and no end, so you've got that rotational aspect. How many ways can 10 people be seated around a circular table?
9 factorial.
9 factorial. Number 30. Sometimes I get a little ambitious when I write these questions. Number 30's got a little tricky aspect to it. Let's start with what you know. How many ways can 6 keys be arranged on a key ring? 5 factorial, right? Key ring's round, isn't it? Okay, but here's the deal. This is the tricky part. A key ring is also small enough for me to hold in my hand, right? So I want you to think about it. Let's say my keys are different colors. So I got my blue key and my red key and my green key. Here's my keychain, okay? So I'm holding it in this hand and I'm looking at my keys. What if I took those keys and I flopped them over in this hand? Wouldn't it look like this then? If I think about holding something in your hand and then just going like this with it. Now, when I draw it on the board, it looks different. But in reality, is it different? Did I rearrange anything?
No.
No, I simply looked at it from the other side. We call that a reflection. A reflection only applies to handheld circular permutations. In other words, circles that you can look at from both sides. So if the thing you're working with is a circle and it's small enough to hold in my hand and there aren't very many things, keychain, bracelet, necklace, that's about it. Then you have to know. No, if there were 6 keys, it's 5 factorial divided by 2. 2 takes care of the reflections. Because there's 2 ways that you can look at each one. Now this is not repetitions. Like we had 2 E's. This is not 2 factorial, even though that's the same number. This is literally dividing by 2, cutting in half the options. Okay? That's one of the finer points of counting. All right, number 31. Now we're making a necklace. We've got beads, and the necklace has a clasp. Now, wait a second. Wait a second. Are you paying attention here? We have a blue bead, a yellow bead, a green bead, an orange bead, a pink bead, and a purple bead. How many is that? 6? We got 6 beads. We're gonna make a necklace. The necklace has a clasp. Abby?
Would the one with the class be 6 factorial?
Bingo, exactly. Do it again. Watch her, watch her. Why is it 6 factorial, Abby?
Because it's a line.
It's a line. If you put a clasp on the necklace, what's a clasp do?
It makes it circular.
What's a clasp?
It's like the thing that like
Who's
connects
got a
it.
necklace on that has a clasp? Anybody have one? Very fascinating. Yeah, it's the fastener. It's a fastener. Learn something every day. It's a fastener. So what the fastener does is, when you go to put that necklace on and take it off, it's actually a line.
Yeah.
So if there are 6 beads and a clasp, it's still 6 factorial. But you still divide by 2. Because you still can have reflections. Any handheld circular object is going to be reflected. Okay, so 6 beads and a clasp is going to be 6 factorial divided by 2. Now, what about same beads but no clasp?
5 factorial divided by
5 factorial divided by 2. Because if it's not a clasp, it's a perfect circle, right? Okay. Repeat number 31, but now there are all of these beads, all right? So I need to write this down. And we're going to do no clasp first. Now, remember, no clasp means it's a circle. All right, so no clasp. We've got 2 blue, 3 yellow, a green, 4 orange, a pink, a purple, and the beads of each color are alike. Okay, now just wait a minute. Wait a second. How many beads are there all together? 2, 5, 6, 10, 12 beads? 12 beads in a circle, no clasp. I'm going to start with 11 factorial. Would you buy that? I'm going to divide by 2 because it's a handheld circular permutation and I have to deal with reflections. What else do I have to deal with? Sir?
repeats,
Repeats.
so you have to do 2 factorial, 3 factorial, 4
Exactly.
factorial.
2 factorial, 3 factorial, 4 factorial. Remember when we had repeated letters? We had to account for that by dividing. Do the same thing. Anything that repeats is handled by dividing by it factorial. Now, there's a lot of stuff in this denominator, so make sure as you're typing it in that you're doing it correctly. I got 69,300.
Yes.
Just like with the letters, kids, the beginning, we don't worry about the repeats. We just count up the total. Now, this time we had to reduce the total by 1 because it's a circle, but we still started with the total beats, just like we started with the total letters. And then we divide by the duplicates. Okay, put a clasp on it. What changes?
It's a line.
The only thing that changes when you put a clasp on it is this becomes a block. Everything else stays the same. You're still dividing by the same stuff. It's just a 12 because you put a clasp on it. Okay. We talked about some pretty special stuff. We have one more concept to discuss. Read number 33. How many ways can 6 couples be arranged in a row if each couple must sit together?
Wouldn't it be?
Now, what that means is, it's not worded very well, but what I mean is, if I go to the movie with Julianne, I gotta sit with Julianne. Okay?
Would you
So I
have,
gotta sit with my couple mate.
so it would just still be 6 factorial, because although there's 12 people, the couples are like being like, it's like they see they have to sit together.
Okay, I love what he's saying. What Sir is saying is, okay, so pretend I got these 6 couples. Okay, I'm gonna bring them in, we're sitting in a movie, okay? So I got them out in the hallway, and I say, okay, you 2 have to sit together. So I tie like an imaginary string around you,
Yeah.
so you are together. So you come in and you sit down together, and then you come in and sit down together, and you come in and sit down together. So what he's saying is, I'm not really arranging 12 people. I'm really arranging just 6, like, bundles of people. So he starts with 6 factorial. That's exactly how you start, but there's more. Sir?
Because like within each couple, they could be,
Exactly.
so like,
When I tied them together, I could tie them together the way you're sitting now,
Yeah,
but I could
or-
also tie you together like that. So when we are grouping things, it's actually called bundling. When we are bundling things, we take the bundles factorial, 6 factorial, and then you must multiply by the number of arrangements of each bundle. So couple 1 is 2 factorial, 2 factorial ways. 2 people arrange 2 factorial ways. Couple 2, 3, 4, 5, and 6. That is the answer to the question. The reason it's 2 factorial, which is the same as 2, you figured that out. The reason it's 2 factorial is because this is how many ways you can arrange 2 people. And when you arrange people, it's factorial. If I had grouped you in 3s, like if I said mom, dad, and kid had to sit together, then it would be 3 factorial, because that bundle could be arranged 3 factorial ways. Donovan?
Can we just run 6 factorial to 2 factorial to 6 factorial?
Yes. Yes.
so
You're
like,
typing it in anyway.
so like in the situation of like, say like, if we're looking like realistically at like a movie theater, and like you may have like a family of 6, and then like a family of 3, and then like a family of 2, would you just do like,
3 factorial, 6 factorial, 2 factorial, whatever, 3
Yeah.
factorial. Yeah,
Okay.
each bundle factorial. Okay, we got some more examples
so
here.
then like what would be the initial factorial though?
3 families, 3 factorial,
Okay.
okay? All right. Here we go, this is another example, this will help you get it. How many ways can you arrange 7 identical algebra books? So the algebra books are all the same. I have 7 of them, they're all the same. I have 4 different geometry books. And I have 3 identical trig books. So they're the same. How many ways can I arrange these in a row? Love it. I start with 14 factorial. But I don't end there because, see these guys? They're the same. And what do I do when I have things that are the same? Divide. So this is going to be divided by 7 factorial and divided by 3 factorial. There are 14 books. In a row is 14 factorial. But this is like having a word with 7 A's. So you'd have to divide by 7 factorial. And 3 C's. In a row, if the books of each kind are kept together. So in other words, I'm tying a string around each group of books. So instead of arranging 14 things, now imagine you got these piles of books and they're all tied together. I'm really only arranging 3 things, so I start with 3 factorial.
Times by 7 factorial times by 3.
But remember, when I tied a string around these, those 7 could be arranged, time out, 7 factorial ways, 4 factorial ways, and 3 factorial ways. When you bundle things, it's bundles factorial times each bundle factorial. But these are still the same, aren't they? So I gotta divide by 7 factorial and 3 factorial because the books are still identical. So as soon as I started writing this, Sir's hand went up. I turned to put it down. Because Sir recognized that if the books are all the same, if these are all identical books, there's only one way to arrange them, right? I mean, they all look the same. They're all the same. Well, what happens is this part cancels out. I set it up in every aspect of the problem there that he's right. We are going to cancel out. Because there's only one way to arrange 7 identical objects. All right, now we're putting them in a row, but only the algebra books have to be kept together. So only these have to be kept together. What do I start with? 8 factorial. That's right. Because I got 3 books, and 4 books, and a bundle. That's 8. So I start with 8 factorial. But I want you to get in the habit of remembering, if it's a bundle, it can be arranged itself. So go ahead and write 7 factorial. That's how many ways a bundle of 7 can be arranged. 7 factorial. These 7 things. But
You divide by 7
we
factorial.
still have duplicates, so we're going to divide by 7 factorial and
3 factorial.
3 factorial. All right, one more problem and then I'll shut up. Number 35. So now we're going back to the old days when there weren't calculators that did this. You have to evaluate that by hand.
10 times 9 times 8.
Well, we have done enough that you're thinking, okay, well, that means 10 things chosen 3 at a time in order matters, so it's 10 times 9 times 8. The formula that, and you're right, you're exactly right. The formula that would generate this is 10 factorial divided by 7 factorial. Now, That means 10 times 9 times 8. Maybe you see that, maybe you don't, but we'll talk about it in a minute. I know where the 10 came from. Where did the 7 come from?
10 minus
Subtract. So when you do a permutation, you do the first number, the big number, factorial, divided by the difference, factorial. Now, 10 factorial is 10, 9, 8, 7, 6, right? 7 factorial is 7, 6, 5, You see what happens?
Yeah.
And that's where your 10, 9, 8 comes in. Now, combinations, 10C3. That actually starts the same way. So I got a 10 factorial over 7 factorial, same thing. But then I have to throw in a 3 factorial on the bottom to divide out all the orders that don't matter anymore. These 3 things I'm picking, the order doesn't matter, so I have to divide that out.
So wait, how will we do that by hand? Or is that by hand?
10, 9, 8, 7, over 7, 6, times 3, 2, 1. Well, everything from the 7 on is going to cancel. So you have 10, 9, 8 over 3, 2, 1, and some stuff will cancel. So you can cancel a 3 and 4, so it's 120. 10 times 3 times 4. The nice thing about factorials is a bunch of junk always cancels out. Okay, is our mind completely blown? You just, I don't want to say learned, I hope you learned, but you were just